Hello, my name is Peter Thomas Miller. I'm the founder of Applied Inspirations, and this is one of our new kits that we've just come out with called the Blinky Board. It's a little bit of retro technology with a little bit of history thrown in, and it doesn't do anything terribly useful, but I think you'd find it very interesting to build. Once we've taken the parts out, these are the parts of the kit. There's also a little teeny envelope with small brass nails, a bit of sandpaper that needs to be opened. Once you've taken off the cover, you'll find inside this guide sheet for the placement of those little nails. So this will need to be cut out. Now the idea of a breadboard, you may have heard of somebody talking about breadboarding a project before, and it means to build the first one. Well, that comes from the infancy of the electronic business, where some engineer on a Friday night probably had an emergency project to get done. Electronic supplies weren't available as they are these days, so he had to be inventive. So he went down to the general store and bought a breadboard, the board you cut and sliced your bread on, and a box of brass nails, hammered them into the board, soldered his parts to that, and that was the way he got his first project done. So ever since then, when we build an electrical circuit for the first time, we call it breadboarding, because the first one was built on a real breadboard. In this case, we have a small block of wood to which I taped this pattern. And the first thing we need to do is define where the nails will go. So that's clearly marked on here. We have to make sure we punch every nail hole. So for this, you need a push pin. The other tools that you really should have, safety glasses. I have these glasses because obviously I'm a little older and need to focus better, but highly recommend safety glasses for any time you do soldering. A good soldering iron, solder. We'll need a small hammer, a pair of needle nose pliers, some wire cutters, and for parts of that, also a set of wire strippers. So we're going to start out by first punching all these little holes. The best way to do is press it down and roll it around a little bit, otherwise the pin gets stuck in there. And I highly recommend you read it through before you start building the kit. That way you won't accidentally jump ahead and have to undo a step. Almost got these all done here. And there we are. Part of what we have under the cover here is a guide for parts placement and the schematic of what we're building. And I highly recommend you try to build from the schematic and then check against the parts placement. As I said before, all the details and the steps are spelled out in this. So we're going to follow through. We punched our holes. Now it's time to tap in the nails. So we will pour out these little nails. Some of the nails are marked in red paint. That's because they're a little larger than the others, so they don't get mixed up. So the first one we have to do is put in the positive terminal. Best way to tap these in is not try to hold them with your hands, but use a pair of pliers to hold the nail in place. The next series of nails we want to put in is the switch and battery contacts. So this first nail is going to be the positive battery contact, and that should be in about the right height, the height of the little positive terminal of the battery. Now we will put in the negative terminal, and we want the high part of the terminal facing over on that side. Now we need something to help the battery from flapping around so they'll stay sprung. We use this little piece of clear plastic tubing, and about in the center of it, I'm going to drive one more nail. Oh, now we have a means to hold the batteries. We'll put them in later, but just to show you, now the positive terminal will press against that nail. And this little springy part will take the negative part of the battery. And now we have a way to provide power for our circuit. Not quite up to that point. Now, the next part we need is a switch. Take another little brass nail and the switch contact and do the similar situation we did for that. Line the hole up with the nail. We want this to be able to move. This one can be tight. This one must move. Now we need to add the ground terminal. So in the kit there is one black wire, and we need to take the insulation off the ends with the wire strippers. And once we get the outer jacket pulled off the wire, just to make it easier for the next soldering job, we want to tin the wire. So here's a little trick I learned. You set up your solder so it's kind of like a cobra. And then I have one hand free. Now I can heat the wire and the solder and melt the solder into the wire. That will make it easier to solder to the rest of the components. Okay, next, we need to have a tin spot on the switch part Now this will take a little more heat to get it going because it's a large piece of brass. It sucks the heat out of the soldering iron. But because it is so thick, it holds the heat. So we have to wait a little longer, maybe blow on it. And now we have a switch. When that slid over there, it'll contact there and bring power into our circuit. All right, let's see what our next step is. So now we have power in place. Now we need to put in the rest of these little nails. Also, try to drive your nails straight in. Everything will line up a little better. That one started off to the side. Now these nails we do not want to nail all the way in. We want to leave them sticking up about a quarter, maybe 3/16 of an inch. All right, I think everybody's in place. Let's just compare to the nail guide. We now need to clean them to make soldering easier. So there's a little teeny piece of sandpaper in there. You want to wipe that over each one of the heads. This will take off any tarnish and oxides, which is hard to solder through, and give a little rough surface, which helps the solder hold on better. Okay, now all we have to do is tin all our terminals. Put a little solder on it. And solder is composed of lead and tin. So the tin lead solders are easy to work with. They do contain lead. That just means don't eat the wire. Don't lick the board, don't lick your hands clean, just wash them when you're done and you'll be just fine. Now that we've got all our terminals tinned, we've mounted our power supply, we're going to need to put in a few additional lines onto this so we can distribute power to the different sections of the circuit. So in the kit you'll find a piece of wire, uncoil it. This wire is already tinned, so all we need to do is we start on the positive terminal. Now that we have that, we will bend the wire down onto this first nail, and that's shown in the diagram and also in the manual. And we want to bend it 90 degrees and go across to these other little nails. So now we will hold this down and solder that in place. Okay, so we clip that wire off. We now have our power distribution. This is going to be a positive terminal of the battery, so power is now going to be distributed to the rest of the circuit. Now we need a ground terminal which distributes the ground signal, the negative part of the power supply to everything. So we're going to straighten out the wire and do the same thing on the bottom set of nails. Periodically wipe your soldering iron tip clean. If it starts building up oxides, it'll be harder to solder. A little fresh solder on it, keep it always tinned. Get the center terminal. We have our power distribution bus. So now the first components we will add are the resistors that limit the amount of current that can flow through the diodes so they don't burn out. We're going to lay it out in its proper place on the circuit according to the layout, and then we're going to bend the lead at 90 degrees so it can fit in there and line up with the power distribution grid. And now we're going to solder that briefly just to the head to hold things in place. Let it cool. Now we'll solder it to the nail at the bottom. Okay, so now we have our three resistors in place. The next element we want to add to our circuit are the light-emitting diodes. Now, they are diodes, which means they will only conduct electricity in one direction. Now we're going to orientate it. We want the flat side toward us, and it's going to go in next to the resistor, but we don't want to solder close to the diode because the heat that comes up the leads could damage it. So we're going to step them off to the side a small amount. And now is when we have to take a good look at how we're bending them. Now, the long lead is going to be at the top of the board. The short lead has the little flat part on the diode. And now I can just hold that over these terminals, and as we did before, heat the nail head. What we want to do now is make sure the diode is in correctly, so we don't solder in everything and discover we've wired things wrong. So we will now need to install our batteries. So now the negative end of the battery is on this piece of brass, the positive end on the nail. So this whole part of the circuit is now positive. Now when I put the switch over, current can flow into the negative lead, and if I've done this correctly, when I touch this, the LED lights. So now I know I have the circuit wired correctly. So if you build and test your circuits as you go, each time you add a new element and test it, if it doesn't work, it's only that new element that can be the cause of your problems. So now we have all our LEDs in place, and we can test them. Light 1, light 2, and light 3. So Now we need to add the kind of magical part to this. This is what changed all electronics, the transistor. It's a little black package. It's like a cylinder sliced with a flat face and has 3 leads. Now these leads also have polarity. The lead over on the far side actually would be this side here. This one goes to ground. The center one picks up the control signal and power flows in on the third one over here. This was called the collector. This is the emitter. The one in the center is the base. It acts like a switch. If I don't put any signal, any voltage to the center lead, it acts like an open switch. If I put a small signal between the center lead and the outer one on this side, it will let a large current flow through. So these have polarity also, but it's pretty easy to work out how these mount. So this is the emitter lead. This is the collector that will control the power, or rather let the power flow, and this is the one that will control it. So a little bit of voltage in here flowing through there to ground will allow a lot of current through this way. Okay, so now we have all 3 of our transistors mounted. Now, we do not need much power going into that, and we don't want to burn up the transistor. So the next components are 100,000 ohm resistors. It's a great deal of resistance because we only need a tiny bit of current flowing in there. And then give it a little bend down so it will sit on the transistor's base terminal, that center point. So now we have the first one in here. This one is called the bias resistor. It provides a little bit of bias to determine how hard this transistor turns on. So now if we power things up by putting the ground in here, we'll find that that LED now lights. The others don't because they're not getting any current. Now what's happening is the current is flowing through this resistor into the base down to ground, and that little teeny bit of current through this large electrical value resistor is allowing a lot of current to flow through the LED. So now we'll solder in the other 2 resistors. Okay, now we have all our bias resistors in and all the LEDs should light. So again, test as we build. So now we know all those circuits work. Now here's where the most interesting part of the circuit comes in that provides its animation. The next component we will add are the capacitors. Capacitors are kind of like storage reservoirs. Kind of like a big barrel with a piece of sheet of rubber in the middle. So if I pump water in one end, and I filled the barrel ahead of time with water, if I pump water in the first end, the rubber will stretch and push water out this side, but only until that stretches all the way to the other side and then it will stop. That's the same thing that will happen with the electrical current with a capacitor. So I'm now going to, following our layout here, insert the capacitor so that it can take power from one part of the circuit and pass it on to another. There we go. And now we have the first capacitor installed. There we go. Now, the last capacitor doesn't really have any more circuitry to go to. We're going to make this a circular one. So it's got to go over to, be bent a little differently, to go over to this nail. So it's a similar bend, but you're going to have to make some small adjustments. It shows you on the parts layout where it's got to go to. So we have all 3 capacitors in place. So what we can do now is take one more resistor, which goes on the end block here. And we're going to wrap the circuit around on itself. So now we've added this last resistor, which is part of what we would call a feedback path. Because we're going to feed this signal back to the beginning of the chain of these parts. And for that, we will need one more piece of wire. There we have our Blinky breadboard. Now if you try to follow the red dot around, you'll get confused. But if you follow the black dot, you'll see that it's off to off to off, and that's what circulates around it. So this is the Blinky breadboard.